All right, here's another example. So we're trying to find dy dx. All right, so for this equation here, and we want to do it implicitly. All right, and so basically what we're going to do, as usual, is we're going to take d dx of everything. You can also write it, you can write a little prime there. Sometimes it looks like an exponent of 1, so that's why you don't do that, but that also means take the derivative of everything. So the derivative of 4x to the 5th is 20x to the 4th. All right, we don't need a y prime there because we're deriving with respect to x. And then here, when we take the derivative of tangent y, the derivative of the outer function, the y part, is going to be secant squared y, right? But then we have to multiply by y prime. And I just put parentheses there just so we know that this is not part of the input there. Okay, so here's the chain rule. Multiply by y prime equals, here we have y squared, so we're going to do 2y, right, is the derivative of the outer function, but then we have to multiply by y prime or dy dx because of the chain rule, and because we're deriving with respect to x. And then finally, we're going to take the derivative of 5x, which is just 5. All right, so now we want to group our y primes together. So you can bring them to either side. Either way is fine. So I can bring my y's to the left or to the right. I'll just bring them to the left. A lot of times that's where we're used to seeing the variables that we're trying to solve for. So bring our y primes to the left. And while we're at it, let's move our x's and everything else that doesn't have a y prime to the right side. So that'll go away. And so we'll get secant squared y times y prime minus 2y times y prime equals, and then on the other side we'll get 5 minus 20x to the 4th. And you could write that, and you could write negative 20x to the 4th plus 5. Either way is fine, of course. All right, so now I want to factor out this y prime here. And so I'll get y prime secant squared y minus 2y equals 5 minus 20x to the 4th. And then we're going to divide everything by secant squared y minus 2y. All right, and so we'll end up with y prime equals this expression here, which I don't see anything that we can simplify. I don't see any common factors that we can reduce by or anything like that. So that's our dy dx. All right. Okay, so yeah, so a little bit of, so really the calculus part was right here, right? And then the rest was just really algebra. And usually, you know, we try not to emphasize the algebra too much in terms of simplifying and things like that. But here the algebra actually helps us to arrive at what we're looking for. So the algebra is necessary in this case, right? So at least that part, right? From here, don't worry about simplifying a lot after that point, unless it's pretty obvious that you can simplify or what you can simplify.